So now we're going to add and subtract rational expressions that have unlike denominators. So the first thing we need to do is make them so they do have a common denominator, and then we can add and subtract them. In order to make them have a common denominator, we need to use that least common denominator that we just talked through in that previous video. So I have some steps up here for us to follow. But what we'll do is we'll kind of go through it with an example at the same time and talk about these different steps, and then we'll do a few examples going through the whole thing. Now, these first two examples, I grabbed expressions that we talked about in that last video, so these common denominators will look familiar to us. Then we'll get to see the application of them. But these last two are completely new expressions, so we'll kind of get to start fresh and see this process from beginning to end. All right. Our first step is to find the least common denominator of all of the denominators. And really, let's sneak in a little extra first step here. Really, first is factor. Factor all of the expressions, especially the denominators, so that you can see your least common denominator. Factoring the numerator isn't as important, and in fact, might want to leave the numerator alone. So let's just say factor the denominator with an S because there's multiple denominators. So with this first expression, we would have y minus 1 in the numerator, and in the denominator we could factor out a y, and then we'd have y minus 5. And then plus 7 over, and that's all factored with y minus 5 squared. So finding the least common denominator for this one, what we saw was that factor of y. We also have this factor of y minus 5, but then we grab the largest exponent, which was that exponent of 2. So there's our least common denominator. Now this step 2, this is one of those steps that there really isn't a great way of writing out in words what we need to do. But what we're going to do is multiply every single term by a unit fraction, or rather each term that has a denominator with it. We're going to multiply by a unit fraction that builds the fraction's denominator up to the LCD. Basically, what we want to see is this y times y minus 5 squared in both of the denominators. So what I would do, and I'm going to go ahead and put this y minus 1 in parentheses here. So just looking at my first term, this y minus 1 over y times y minus 5. What I need to see is what I'm missing in order to make my denominator y times y minus 5 squared. And if it even helps, you could write this without the exponent. This is the same thing as y times y minus 5 times y minus 5. So with that, I can see I'm missing a second y minus 5 here. So what we're going to do is multiply by a unit fraction, meaning this fraction that I create has to be equal to 1 right here. So whatever I put in the denominator, I have to put in the numerator too. And really, I'm just focused on the denominator right now because that's what I need to change. So we're missing a y minus 5, so I need to multiply by y minus 5. And then whatever I put in the denominator, I have to put in the numerator as well. And then we have plus our second term of 7 over y minus 5 squared. So I need to multiply this, and my missing factor is just y. I already have my two y minus 5s, so I need y. And whatever I put in the denominator, I have to put in the numerator. Now, over here, I'm going to FOIL this out, that y minus 1 times y minus 5. I want to multiply this out because I'm going to end up adding 7y, and I want to be able to combine that all together. And I can't combine it all together if those are trapped in parentheses there. So I'm going to FOIL out, so we'd have a y squared. See, minus 1 minus 5 is a negative 6y. Negative 1 times negative 5 is positive 5. all over y times y minus 5 squared. And then we're going plus 7 times y over y times y minus 5 squared. So now we have our common denominator, so I can add them together to be all over y minus 5 squared. And let's see, we'll have y squared, negative 6y plus 7y. So that'll be plus y plus 5. And then at this stage, what I would try to do is factor that numerator there, see if I could simplify, see if I can get anything to cancel out. But that 1 and 5 as a factor is not going to add up to 1 at any point, so that will be stuck, and that's our final answer. So the steps we go through: first, factor the denominators, multiply by unit fractions, so they have to be equal to 1 because this isn't an equation. We can't just multiply by anything. This is an expression, so we can multiply by 1 because then it's not really changing anything. When multiplying out, simplify your numerators so that you can see how they'll add or subtract together, and then carry out your addition. And if we can simplify, we would, but in this case we couldn't. All right, let's go through the same thing here, but with subtraction. So we'll have 3 over x squared plus 4x plus 4, so that's our x plus 2 squared. Again, if you want to write it expanded out as x plus 2 times x plus 2, that works great as well. Over x plus 5 over x plus 1 times x plus 2. Now, for the least common denominator, we're going to have an x plus 1, and then we're going to have an x plus 2 squared. Sorry, I'm going to write this up a bit higher, because I'm going to go ahead and do my math on here. So 1x plus 1, 2x plus 2's. So my first term, I need to multiply by a unit fraction. I have my x plus 2 squared. What I'm missing is the x plus 1. And whatever I multiply in the denominator, I have to multiply in the numerator as well. For this term here, we have everything, but we need another x plus 2 multiplying on. So I'm going to multiply by another x plus 2, multiply by x plus 2, and just remember that we have those parentheses there around that x plus 5. All right, so now I'm going to have these two denominators that match up with an x plus 1 times an x plus 2 squared. In the numerator, 3 times x plus 1 will be a 3x plus 3 over that x plus 1 times x plus 2 squared. And then we're subtracting with, and I'll go ahead and FOIL this out, so we'll have an x squared plus 7x plus 10 all over 1x plus 1 times x plus 2 that's now squared. So what you can think about through this is kind of keep the numerators all simplified and expanded out. Keep the denominator factored, because in the end, in order to simplify, we'll want to see the factored form. But in the process of adding and subtracting things, we'll need to see it expanded out. So we kind of treat the numerator and denominator differently here. So in the numerator, we're going to have that 3x plus 3. And then remember, with subtraction, we're going to bring parentheses with it. And if it helps, you could think of it in this stage of we're distributing the negative in. So I'm going to have a minus x squared minus 7x minus 10 all over x plus 1 times x plus 2 squared. And then we'll just combine like terms. So we have that negative x squared. Let's see, 3x minus 7x is minus 4x. 3 minus 10 is negative 6. Nope, negative 7. There we go. So that works great. Having a negative out front there, we could factor out the negative. So we could bring the negative out front of the fraction, and that would essentially bring a negative out from every single term in that numerator. It's the idea of factoring out a negative 1. So that would make for a positive x squared plus 4x plus 7 all over x plus 1 times x plus 2 squared. So it's like factoring out a common term. It's just a negative number. Then I would see if I could factor the numerator at all, which that's going to be stuck. So then I would just leave it in that form right there. This first form is fine too. It's just sometimes factoring out the negative can look nice, or it can make it easier to factor when we're in the trinomial form. All right, I am going to go through 2 more examples here so we get lots of good practice. So here we're going to have 2 over x plus 3 times x minus 3, using that difference of squares, plus 1 over, we have a common factor of 3 to factor out, and that would leave us with an x plus 3. So my least common denominator, we have a factor of 3, we have an x plus 3. Both of them have an exponent of 1, so we're just going to have one of those x plus 3s and the x minus 3. So for my first term, all we're missing is a factor of 3. So I'm going to multiply by a 3 over there. And on the right-hand side, I'm missing the x minus 3. So I'm going to multiply by that factor of x minus 3. So in the numerator, we have 6, and then over 3 times x plus 3 times x minus 3, plus 1 times x minus 3. So we'll have an x minus 3 there with a 3 times x plus 3 times x minus 3. So now we have our common denominator. So it would be 6 plus x minus 3 over our shared common denominator. 6 minus 3 is a positive 3. And now I can see this common factor of x plus 3 across the numerator and denominator. So those would cancel out with each other. So we're just going to be left with 1 over 3 times x minus 3 for our final answer. All right, our last one here. So first step will be to factor the denominators. So this will be a x minus 4 plus 2. And then minus 1 over x plus 1 times x plus 2. So for our least common denominator, we have the x minus 4. We have the x plus 2, we have the x plus 1. All right, our first term here is just missing the x plus 1 from the denominator. So I'm going to multiply by an x plus 1 over x plus 1. And then over here we're missing the x minus 4. So I'm going to multiply by the x minus 4. All right, on the left-hand side here, that 6 will distribute in, so we'll have 6x plus 6 over this whole x plus 1 times x minus 4 times x plus 2, and then minus 1 times x minus 4, which is just x minus 4, over x plus 1 times x plus 2 times x minus 4. All right. So we're in the numerator, we'll have the 6x plus 6, but then that subtraction needs to distribute into that x minus 4. So we'll have that 6x plus 6, but then minus x plus 4. all over x plus 1 times x minus 4 times x plus 2. So 6x minus x is 5x. 6 plus 4 is 10. Looks like we have a common factor of 5 up there, so now I'm going to factor. So factoring out the 5 would leave us with an x plus 2, so we're going to have something that can cancel out. It always feels good when things can cancel out, but sometimes you can't, and it can make it feel like it's a wrong solution, but it's just sometimes we can cancel things out, sometimes we can't. So we just have to be comfortable with both scenarios. But it does feel good when it simplifies. All right, so that's our addition and subtraction of rational expressions when they have unlike denominators. Just keep in mind, this is something throughout our whole algebra class, this difference between simplifying expressions versus solving equations. Notice with these, we don't have an equal sign when we start. And really, we shouldn't have an equal sign at all during our work. All we're doing is taking this original expression and simplifying it down. So this 5 over x plus 1 times x minus 4 is the same exact thing as what we started with at the beginning. It's just in a simpler form. But we didn't solve for anything, and when we solve equations, we have a little more freedom in terms of what we can do, because whatever we do to one side of the equation, we can do to the other. But in simplifying expressions, it's much stricter in terms of what we can do, and the idea being we don't want to change the value of anything, so we have to only multiply by versions of 1 with our unit fractions. So just be careful with this. With these, if you ever end up with like x equals 3, that can't happen with these. You can't end up with an equal sign. We're not solving for anything. We're just making a simplified version of the expressions.